another Leetcode video. In this video we will be doing question 3 of the July Leetcode challenge, and the question name is prison cells after n days. So there are 8 prisons in a cells in a row, and each cell is either occupied or vacant. So there are 8 numbers and they are either occupied or vacant. In each day, whether the cell is occupied or vacant changes according to the following rules. If a cell has two adjacent neighbors and are both occupied or both vacant, then the cell becomes occupied, otherwise it becomes vacant. Note that because the prison is a row, the first and the last cells in the row can't have two adjacent neighbors. We describe the current state of the prison in the following way. If cells of I equals to 1, that means it is occupied. If cells of I is not equals to 1, so the immediate state it would contain is 0, that means it's not occupied. Given the initial state of the prison, return the state of the prison after n days and n such changes described above. Great. So let's understand the question. We have 8 digits, okay, they all are 0 or 1. 0 represents, and these 8 digits represent one cell, and these all 8 different cells represents a prison. Now some people are there in the prison, some are captivated, some are not. So the people who are there in the prison, okay, so let's say I have a value here, okay, so I have a value 0 over here. Now if I have a value 0 over here, I would see its neighbors. So if the neighbors are present, so or absent, so both of them has to be true. So if the neighbors are present or absent, that means if my immediate zeros neighbor is what, right and left, so since I have no left neighbor, this cell would always be unoccupied. Now coming to this particular cell, according to rule number 1, if this, I would go ahead and check its neighbors. So the neighbors are 0 and 0, so both of the neighbors are equal. So here is the see, both of the neighbors are equal and both are vacant. Then the cell becomes occupied. So I'll go ahead and change this 1 to 1, but actually that means there are no toggles because 1 will remain 1. Now go to this particular 0 and see its neighbors. Left and right hand side of the cells are 1 and 1 each again, so they are same. So this 0 would change to 1. So hence if you see, this 0 has changed to 1, right, in the second day. Yeah, this one, the 0 has changed to 1 in the day 1, right? Now go ahead and check this. It has 0 and 1 on the left and right hand side. Keep in mind that we are not checking the updated value on the left, we are checking the current value. If I am at day 1, so I would check the day 1's value and not the updated days 2's value. So this 1 would be checked with this 0 and this with 1, so they are both are unequal, so this 1 would get toggled to 0. So if you see, it's nothing but a XOR operation. If both of them are unequal at a particular cell I, if I minus 1 and I plus 1 they are equal, so equal means they can have 0 0 or 1 1. In that case I will have cell of I, that is the cell under consideration, would be 1. So it's just the inverse of XOR. So what I will be using is not of XOR, right? So that's for the updation part. Now the main what makes this question a little tricky is the value of n. N's value is as large as 10 to the power 9, and I don't I don't think any any programming language or any technique which has O of n complexity would not give a time error in this input range. So what I'll have is let's say I have 10 to the power 9, so I cannot go and do this swapping and XORing operations, although it's constant, because they are happening in only 8 number of cells. So always the XOR operations will occur in 8 cells. So although they are constants, but I cannot just go and have them for 10 to the power 9 number of times, and at the end of 10 to the power 9th day I would tell that this is my prison. Had this be somewhere around 10 to the power 5, 10 to the power 6, then O of n complexity would work fine. So what technique we will use here is nothing but the concept of permutation and combination. So if you see this, since this is a binary string, and I am sure that you are convinced that the leftmost and the rightmost, right? So let's leave alone the initial configuration. From any day, from day 1 to day n, the leftmost and the rightmost cell would always be unoccupied because they have no neighbors. Now this is quite clear that the cell of 0 would be 0 and the cell of 7 would be 0. So how many cells we are left with? We are left with 6 more cells, because since the total number of cells is 8, 2 have a constant value of 0, so I have left with 6 more cells. Now these 6 more cells will have at max 2 to the power 6 number of combinations, so that's around 64, right? So 2 to the power 6 number of permutations would lead us to 64 different patterns. Now it doesn't matter whatever big the value of n is, the number of combinations, distinct combinations, or rather I would say distinct permutations, would be nothing but 2 to the power 60 2 to the power 6, which is equals to 64. So what we need to do is we need to reduce this n to anywhere between 1 and 64. And how do we do that? Let me demonstrate you an example. Let's say I have a pattern, I have a sequence, right? So p0 is the initial pattern, so let's not have it, let's say it's initial, right? Initial is at day 0. Now let's say p1, p2, p3, p4, p5, again p1, p2, p3, p4, p5, p1, p2, and so on. So if I have been asked what is the configuration at the 10th day, so 10th day is what? This is day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8, day 9, day 10. So it would be p5, right? My answer would be p5. So one thing is I generate the whole string, or another thing is I find out where is my pattern reoccurring again. So the place where my pattern would reoccur again, in that place, that this is where the point that I would leave. So what I mean by say is, let's say I pondered upon p1, I would go and check, I would have some kind of data structure, maybe map or set, to see whether I have previously seen p1 or not. So no, I haven't seen. Okay, great. So I'll go ahead and do to p2. Have I seen the pattern p2? No. Have I seen the pattern p3? Nope. Have I seen the pattern p4? No. Have I seen the pattern p5? No. Have I seen the pattern p1? Yes, I have seen the pattern p1 again, and it is how many steps ahead I have seen it? I have seen it in 5 number of steps ahead. So the pattern length that it's repeating is 5. So if I have at at day equals I, if at day equals I have a repeating pattern, so the number of the sequence or the length of the pattern which is repeating is nothing but I minus 1, because p1 is occurring at the 6th day, and so that means I have 5 number of patterns that's previous to p1, so I have a length of repeating pattern of 5. Now what I'll do, I'll effectively reduce. So I was told to find the pattern at day 10, so I'll know that my value of the repetitive pattern is 5. So I'll go ahead and do 10 mod 5, that would give me 0. So I know that the pattern at day 1 at day 10 would be nothing but the pattern at the first initial day. So basically what I mean is the pattern at day 10 would be, let's go ahead and see, 1 2 3 4 5 6 7 8 9 10. It's nothing but p5, right? The pattern is p5. Now I have a pattern length of 5, 1 2 3 4 5. Now I go ahead and do a mod operation, and I see that it's 0. So that means the last pattern that I pondered upon is the pattern that I should have. That should be my answer. So let's if you don't understand, let's go ahead and say for 11. Okay, so if it is 11, so 11 is nothing but 1. So the last pattern I pondered upon was p5, I pondered upon was p1, where I found that my pattern is being repeating. So what I'll do, I'll see my p1, and from p1, right, so I'll have at p1, right, so the first pattern is p1. So I know that p1 is a repeating pattern, and if 11 mod 5 is 1, that means I have the first 5 elements that's being repeated, and since it's 1, I would choose the immediate next element after the repeating sequence ends. So that's nothing but p5, and the immediate next element is p1, because p5 is where the repeating sequence ends. Let's go ahead and take another example. Let's say I've been given the value 13 mod 5 is nothing but 3. So at P1 I realize that I have a pattern. So the pattern length is what? 1 2 3 4 5. The pattern length is 5. So I'll do 13 mod 5. I'll get 3. So the last value I pondered upon was P1. From P1 I can go either 2 values, or from P5 I can go 3 values. So the end of pattern is P5, and from that I have to go 3 values. So that's P1, P2 and P3. P3 is the point where that the pattern that I'll get. So if you see, the P3 is the 13th day, right? 1 2 3 4 5 6 7 8 9 10 11 12, and after this 13. So P3, right? So this P3 is nothing but equal to this P3, which is nothing but equal to third day. See, this is the third day. So I am effectively reducing my n from 13 to 3. So like this, I'll at max have how many patterns? At max I will have 64 patterns. So the remainder of 64 would be anywhere between 1 to or 0 to 63, right? Correct. So I'll have only distinct 64 number of patterns. I won't have any much. So whatever be the n is, my n would always be reduced to 64. This is the trick. So let's go ahead, and I would use a set data structure to see what patterns I have encountered previously. Now I'll check. The first thing is, if n is equals to 0, right? If at any stage is n is equals to 0, I'll go ahead and return cells. There's no changes. Now if let's go ahead and say int I equals 0, I would be using this I. That's why I'm declaring it not in the for loop. So how I would be using it will be like this. So let's say I'll update here. Okay, so updating, I'll use a temporary vector to store the cells. Why I'm doing this is because, as I told you, while updating I should keep in mind that I don't take the current updated value. So when I change this 1 to 0, considering its neighbors 0 and 1, I should keep in mind that I should not consider this one, because this one has already been changed earlier. So there's a high probability that I consider my current state. So I won't be considering my current state, I would be considering my old state. So in this temp I would save the old state. Now what I'll do is, I would update this temp to the current state. So temp of 0 would be nothing but the not of or 0, it would be nothing but 0, right? And temp of 7 would be nothing but 0. Now the first thing I need to see, okay, so before doing that, before updating 7, what I'll do ahead, I'll have temp of 1. Why I'm not updating 7 first? Because if let's say for this example I updated 7 to 0, then for this 0 would have to become 1, because this is 0, this is updated to 0, so 0 and 0, this should become 1, but this is actually 1. So I'll have to update it in sequential manner, right? So temp of 1 would be nothing but let's go ahead and do one thing. Let's run a loop from int j equals 1 to j less than equals 6 to j plus plus. So this loop would be run in constant time, because it's always running for 6 number of times. So I'll have temp of I not of cells of, that is cells is the current the previous state, and temp stores the current state. So I'm updating the current state. I'll be doing j minus 1 XOR cells of j plus 1, and I would do a not operation. So that's not of cells of this or is this. So at the last, what I'll do is, since I've updated, I'll do a temp of 7 equals 0. This is what I'll do. Great. So my temp value is updated. So basically I've constructed P2 from P1, or rather in the very first initial time I've constructed P1 from the initial. Now let's say I've just now constructed P5 from P4. So I'll see that P5 is there or not. So if it's not there, I'll go ahead and enter it into the list or enter it into the set. Now I've just constructed P1, so I'll see whether P1 is there or not. Is P1 there? So I'll go ahead and check. Okay, so one thing, yeah, yeah, perfect. I'll go ahead and check if s dot contain, or rather count, right? If s dot count of temp is equal to 1, so if the pattern p1 is already there, so what is my current what is my pattern length? That is my current day. The current day is 6, but my pattern length would be I minus 1. That's nothing but 5. So what I'll do is nothing, I'll just break away from here, and I would use the I value. That's why I kept I as the global variable, or rather not a variable inclusively for the loop. So I'll just go ahead and break. So if s dot count temp equals to 1, I'll break. Else what I'll do, I'll just s dot insert temp, and also I'll update my current to be temp, and yeah, that's all. So from here I would get my repeating length, right? So from here I would get my repeating length. Let's remove this. Yeah, makes sense. Yeah, so from here I would get my repeating length. Now what I'll do, I know that how many times my pattern repeats. Now I'll go ahead and make the original n that was there, I would make it n mod I minus 1. That's what I'll do, because I minus 1 is the length of the repeating pattern. So while now whatever be it, right? So if it's 3, if it's 4, you see what I did earlier. So when I had p1, when I had a repeating, I'm not updating. See, I'm not updating, I'm just breaking out. The updation takes place here, current equals to temp. This is the updation. I'm not updating, I'm breaking it out. So the last pattern I encountered was p5. Now from p5 I'll traverse 1, 2 and 3. So while n minus minus, this is what I will do, I'll traverse 3. I'll just go ahead and update. So updating again, maybe let's do one thing, let's make it free from any loop conditions. So temp would be equal to cells. So again here nothing but temp would be equal to cells. Now I don't have to check for any patterns or not, because I can seriously go and check for all the n elements. I can do it n number of times iteratively. So I'll have this. I'm just go ahead and copy pasting it. So I'll have this. I'll have temp of 7 equals 0, and at the last I'll just update. I'll update for n number of times, small n number of times, because I am guaranteed that small n would be anywhere between 0 to 63. So I'll go ahead and update, and I'll do current is nothing but equal to temp, and I think that's all. At the last I'll return current. Okay, so I'm extremely sorry, there's no variable named current, so this will be cells. Okay, so I'm updating the cells. At the last I'll return cells. So yeah, I think this code will work fine. Let's go ahead and run some cases. Okay, so there's a n expected. Okay, so let's see where's the error is. So I'm extremely sorry, this would be for I equals to 1, I less than equals than I plus plus. Yeah, so I think now this should work, right? Yeah, let's see. Okay, so here for this big example my answer doesn't matches, so there are some problems. Let's see what the problem is. So let's go ahead and look it through code by code. If n equals to 0, I would return cells. I have no issues in that. I'll go ahead and do int I equals 0, yeah, whatever it is. Now I'll have vector int of temp, which is this. So I'll have temp. Okay, so I'll have maybe I can do this also, it won't matter hardly. Yeah, so yes, I start from 1 to n to I plus plus. If temp 0 equals 0, right, temp 0 would be equals to 0, and in j equals 1, j less than equals 6, j plus plus, I'll have temp of I. Okay, so here's the error. So I'll have temp of j is equals to cells of j minus 1. Yeah, so it's not I, it's j. So temp of j would be this, and temp of 7 would be this. So updation is done, and I'll see whether the pattern is already there or not. If the pattern is there, then don't update in the original string. I'll just break, and the pattern length will be nothing but I minus 1, because if it's here at 6, then the pattern length would be 6 minus 1, that's 5. So do a 10 mod 5 or anywhere. So if 13 mod 5 is there, 13 mod 5 will give me 3, so that's nothing but 1 2 3. So p3 would be my answer, so that's why I have done this. And temp of cells in j, and temp of j here also, j minus 1 and j plus 1. Temp of 7 would be 0, cells would be updated, and I would return cell. I think this time it would run. Let's see. So that was a mistake. I did my yeah, it's giving me the correct answer now. So let's go ahead and submit and see. And it's accepted, right? So this is a very interesting problem. It's not like any trivial problem that I think you may have encountered, but it's a very interesting problem. These are the problems that you should practice. And if someone asks you what is the maximum, what is the complexity of this whole code, then if you dive a little deeper, then you would see that the first loop n would never run more than 64 times, and the second loop n would also never run more than 64 times. So that's a constant time complexity, if you say in this way, because no matter whatever the value of n is, the pattern should and it must repeat after 64 times at max, right? It may repeat earlier also, but at max it should repeat after 64 times. So yeah, this was the problem. I think you have understood, and this is the type of problem that you should keep in mind while doing all this stuff. And thank you, and don't forget to press the like button and subscribe button. Thank you.